Welcome to Math 20, Workplace 20 in the PM. I'm your host, Mr. Shidelka. Here we are. Look at this, I got my special logo, Workplace Apprenticeship 20. Bell for bears, right? So I designed it, especially for you guys. Bear math. Anyways, bar graphs. There's a difference between histograms and bar graphs that we're going to get to. A bar graph, though, is used to plot discrete data. What do I mean by discrete data? Discrete data has no in-between values. So the number of people in your class, you either have 20 or 21 people, never 20 and a half, right? It's one or the other, no in-betweens. Whereas temperatures aren't discrete values. You can have a temperature of 20 degrees, 20.1 degrees, 20.2. You see what I mean? Those aren't discrete. So discrete means one or the other. And often it's even descriptive. If I did a bar graph of who likes Pepsi, Coke, and root beer or something like that, A&W root beer maybe, you know, that you can't be in between. It's Coke that I like best, or it's Pepsi that I like best. So, make a bar graph. What are we going to expect to do? I would expect you to do it neatly. Use a ruler if possible. If you can freehand it, some people are real artistes. That's fine. But let's look at this. Display the data on a bar graph here from the population of cities from 14 years ago. Now, the population's in thousands, so really Vancouver is 1,987,000. Well, you don't need to write all that out. Here's what we're going to do on the side. Label it as population, and then in thousands. And on the bottom, we're going to have the city. Now, I got to keep sliding back and forth to see this stuff. Right, Vancouver. So this is what Shana was asking about the other day. Can I just put Van? Sure. Calgary. Vic. Ed. Saskatoon. Winnipeg. And then Regina. Eagle Ridge. Make sense? And then the population. Always look for your highest and your lowest of the thousands. Regina's the lowest at 193. Going up to 1987. So that's practically 2,000, right? 2,000 times 1,000. It was 2 million. Tony, I forgot that you're in on this too, right? So, you with us up to here? Good. So, let me see how many squares I got. So if this was 0, and I want to get up to 2,000, let's see if this works. Well, quickly, if I go 2, 4, 6, 8, 1,000, I can already tell I'm not going to get to 2,000. Okay? So I got to do, I can see it now. Let's think of it this way. If this is 0, and this is 2,000, uh-oh, I used the wrong marker. Where is it? I thought that was the fadeaway. Anyways, I'll go like this. If this is 0, I can see it'll fit perfect. Why is this not working now? Okay, that's 2,000. How can I fit these all in? Well, look at this. There's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the midpoint should be 1,000. There's really 1,000 times 1,000. It's a million people. Well, I'll use 1,000. And then the midpoint of that is 500. That's 1,500. It's really just trial and error how you fit everything on a graph. And I picked 2,000 because that'll fit Vancouver's population in 1987, right? 1.9 million, practically 2 million. Then, here's where a bar graph is different from a histogram. Because you can't be Vancouver and blend into Calgary, the bars can't touch each other. Okay, I'm not drawing accurate bars here, but you see there has to be space in between each. Don't do this, and then have the next graph bar like that, and then you see what I'm saying not to do? Don't have them touching. That's a bar graph. So, what do? You take Vancouver. I've got a It's easier for me, but I could go like this. Vancouver is practically right up to there. Well, I guess I'm pretty messy though. But you get the idea. That's 1987. It's just shy of 2000. Whereas Calgary is just under 1 million that year. 951. I'm going to pull this out again. I guess this would be 250. Just to help me out a bit, these others. So 950 is just a shade under 1,000. So I'm going to go back to this. 950. Oh, not that much under. Oh, not. This gets in great here. I just can't seem to do anything with this. I'm going to try to walk this in. Try to do lock. Anyhow, 950-ish. Should be less than that. Skim something off the top. Won't. There we go. Mine's crappy. Actually, I got to use a different one. This just sucks. But you guys draw in your bar graphs, okay? You guys know what to do. I don't know. I think you know what to do, right? Give you a little bit of time there. Victoria 312. Saskatoon. And 671 full with interface. Lastly, old Regina. Home sweet home. Hopefully your graph looks something like that. Oh, wait a second. Because the last one's fairly easy. And then we'll use the pen. You guys even need more help? You guys would know how to read graph, right? Okay. I think you're good then, eh? You're good. Sure. Tony, are you okay on this kind of stuff?
Yeah.
Okay. I'll just do an old flipperoo. If you guys can get back to that, I'll just run through this one page here so I can help Faith and Tia on the other thing. Okay? So just flip the page, Justine, and then you can come right back because you'll know what you're doing. Okay, I've got two graphs on this one. One's big, one's small. But what are these? Reading the graph. Roger's a real estate agent in Red Deer. The graph below compares his average house prices of a new single-family home and a resale or not new single-family home. Not apartments. These are single-family homes. You know, that's what we mean there. So the resale homes are the dark bars and the grayish bars are the new homes. Now, let's just take a look here. What's the questions here? What's the average price of a new home in 2005? 2005, new is the gray one. It even reads there, it's 240, right? 240,000. There's no biggie there. Between what years is there a drop in the price of single resale homes? Let's go here. you look at resale, isn't it that's the black. Okay, 2007 and 8. Do you see how there's a drop from 355 to 350? And then there's a drop there. You see what I'm talking about there? We're looking at the resale homes, and they drop from 355 to 350. Then the following year, they drop again. So between 2007 and 8, and the 8 and 9, there's drops in those prices. The other ones are increasing, actually, but what years was there a drop in the price of a resale hand with home? 2000. Redo that. 2000. I can't write anything to this. Okay, between 7 and 8, and then the years 08 to 09. Those are the years that there's drops, right? Every other one. Scanning up. Yeah. What's the general trend in prices? Which costs more? And which years was it not so? Usually, which type of house costs more? Usually. A new house. Usually. There is an exception, though, in 2 different years. So, just a second here. New houses are more, usually, except in 2000. Which 2 years is the resale homes more expensive? At a glance. 6 and 7. Thank you. Okay. By the way, I just want to show you the exact same data, but look at this stacked. You'll see this sometimes. I don't like these kind of graphs as much. Because can you tell, like in this particular year, 2007, can you quickly tell which is worth more, the resale or the new homes? It's harder to tell on this stack thing, eh? When you go up in the other one, no? It's actually the black, the resale is worth more. And it's hard to tell from this, I'd say. Like, do you follow what I'm saying? I find these ones harder to read. But it gives you the grand total at least, though. Anyways, I just thought I'd point that out. You guys finished that first page which you were working on, then you got 2 more to do. It should be reasonable, I think. Okay? Good. So, I'm going to stop this recording.